in this lecture we will learn about the ellipse, and we discuss the definition of the ellipse and discuss its elements, and secondly we will derive the standard equation of the ellipse. So before going to the definition, we know that in conic section, when the eccentricity is lie between 0 and 1, then it forms an ellipse. So the equation of the eccentricity is E, which is equals to C over A, which is very important. Basically this describes the conic section, that which conic section exists, which is a circle, parabola, ellipse or a hyperbola. Means the C lie between 0 and A. The E in that case is this for ellipse. If E is equals to 0, then it forms a circle. If E lie between 0 and 1, then its shape is just look like a ellipse, a stretched circle. Basically, E describes the shape of a conic section, that it tells us that it appears as a circle or a ellipse or a parabolic shape. So now move to our main topic, which is the ellipse. Definition of the ellipse. Check out the definition. An ellipse is a set of points in a plane whose distance from two fixed points in plane have a constant sum. Mean I have these two fixed points, and let's suppose I have this point, which is I suppose a point P. Then the distance between this fixed point to this point plus the distance between the point to this fixed point, if I suppose this point is, this distance is d1 and this distance is d2. So what the ellipse says, so I write d1 plus d2, which is equals to, I will suppose any just a constant length, which is alpha. Then if ever I suppose all these points over here, then the distance is always remain same. For example, I will form a shape of the ellipse, which is just look like that ellipse. If I take a point which is something here, and I suppose this point my is P1 point, and the distance of this point to this fixed point is, let's suppose, D3, and the distance between to a point P1 to this fixed point, I will suppose the distance is, let's suppose, D4. Then by the definition it will be D3 plus D4 is equals to, I suppose, alpha. Means the distance is always same, and this is as the ellipse is formed with such of many points. So the two fixed points in a plane is called a focus. Means here is a first focus and here is a second focus. In the ellipse there is two focus. So the two fixed points are called a foci of the ellipse, and the point half away between the foci is the center of the ellipse. Means a point where is a center point of these two foci points is called a center. Basically this is a center point. Secondly, the line passing through the foci, these two are the focus. The line passing through a foci of the ellipse is called the ellipse focal axis or a major axis. Means this line passing through these two focus is called a focal axis. We sometimes say that it is a focal axis, but frequently we use it as a major axis. So at this point the focal axis and the ellipse cross or cut each other, so this is a vertex. And in a similar way, here is another vertex of the ellipse. And always remember one thing, that a focus of an ellipse always lie on a major axis. As in a further we will derive the equation of standard equation of the ellipse. So as in the ellipse there is only two possibilities of the ellipse, as when the focal axis or major axis on a x-axis, and the other possibility of the ellipse is that when a major axis is on a y-axis. So we will derive the equation of the ellipse when the foci lie on a x-axis and center is at origin. So we will derive it. So suppose that the foci of an ellipse are a point which is F1 having a point minus C0 and the other point of the focus on a ellipse, which is this. And the sum of the distance of all points on a ellipse to foci is constant, which is 2a. So we have to derive the equation of the ellipse when the foci on a x-axis, means here is a major axis. So means I have the ellipse shape just like this form, and I have two focus points, which is this focus point, which is f1 minus c0, and here is another focus point, which is f2 c into 0, and in that case I have a center with the origin. This is a center which is origin. I have a point P having coordinates x and y, then the distance of all points, and I suppose this point P on the ellipse to these two foci are a constant, which is 2a. If I suppose this is a distance and this is a distance, then the distance of these two means, if I will suppose pf1 distance plus pf2 distance, which is equals to 2a, which is a constant, and c is lie between 0 and a. So the line through the foci and across the ellipse, that here is our two foci on this axis, so this is called a major axis, or we already discussed that we also say that it is a focal axis. And a line passing through a center, which is here is the center, and perpendicular to this major axis, as this is a major axis, and a line which is perpendicular to this major axis and passing through a center is called a minor axis, means here is minor axis. And we already discussed that a point where a major axis and the ellipse cut is called a vertices. So here is two vertices. I will suppose here is a vertex point, which is a dash, having a coordinates which is minus a and 0, and here is a vertex point which is a, which is positive a into 0. As always, remember that the distance of a center to this vertex is a, means this distance is a, and in a similar way this distance is also a. And one thing is that the distance between a focus and a center is c, means if I say that this is a center point, this is a focus point, then this distance is point c. A dash is basically the vertices of the ellipse, as I suppose this point is b and this point is b dash, and similarly we find the coordinates which is 0 b, and here is the coordinates which is 0 minus b, and these are co-vertices. A dash line is called a major axis, and A dash is a vertices. In a similar way, B dash is a minor axis, and B dash are called the co-vertices. So now we find the equation by using a distance formula between a point Pf1 and Pf2 by formula x minus, the other point is minus c and the whole term is in square, plus y minus 0 square with a radical sign. Now the sign is plus, the other distance is Pf2, means these 2 points distance, so it will be x minus c square plus y minus 0 square, and the term is in a radical sign which is equals to 2a. So before taking a square, we just do a one step, that if I move any one of radical to other side for simplification, so if I write x minus c square plus y square with radical, means this term I will take in this side, which is equals to 2a, and move this radical, this factor on the other side, so it will be minus x plus c square, because minus minus is plus, plus y square with a radical sign. Now it's time to take a squares on both sides. So if I take square on both sides, so this radical can be removed. So we will left with x minus c square plus y square, which is equal to, and this whole factor is in a square, which is 2a minus x plus c square plus y square, as we can't do the step that this radical can cancel out the square and it will be 4a square. This is not possible. We here apply a formula of a minus b square. So x minus c square plus y square, which is equals to, so it says that 4a square plus x plus c square plus y square, and the sign is minus 2a x plus c square plus y square with this radical. So here what we use a minus b square, which is equals to a square plus b square minus 2ab. So we use this formula over here. So in the next step we just simplify here and open the square of this factor as well. So it will be x square plus c square minus 2cx. We apply our formula, which is this formula over here as well, and plus y square as it is, which is equals to 4a square plus, if I open the square of this factor, so it will be x square plus c square plus 2cx, and plus y square, and this factor will be minus 4ax plus c square plus y square, and this factor is in our radical sign. So now it's time to solve it. As you see that this is positive x square and this is also positive x square, so these factors are cancel out. In a similar way, this c also cancel out with this factor, and this y square also cancel out in this step as well. So we are left with the factors, which is 2cx, which is equals to 4a square plus 2cx, and here is a minus 4ax plus c square plus y square, and this factor is in a radical sign. Now it's time to rearrange all of these factors. If I move this factor on other side, so it will be positive. So I will write it as 4ax plus c square plus y square with our radical, which is equals to 4a square plus 2cx, and this factor on other side, so it will be plus 2cx. We just rearrange all the factors here. Now we simplify here 4a x plus c square plus y square with our radical, and 4a square plus, if we add these two factors, so it will be 4cx. So now we divide whole the equation by 4, because here is a common of a 4. So in the next step we will write x plus c square plus y square, and this term is a radical, which is equals to a square plus cx. So here we are not able to derive the equation to any equation. So in that step we are facing this radical sign, so we get rid of this radical sign by just taking the squares on both sides. So if I write a step which is x plus c square plus y square with a radical factor and a square, which is equals to a square plus cx with the factor of a square, and in this factor this radical sign will be removed. So I will left with x plus c square plus y square with multiply this factor. And if I open this square by just applying the a plus b square formula, so it will be a4 plus c square x square plus 2a square cx. If I divide a square on both sides, then I will get with x plus c square plus y square, which is equals to, if I divide a square, so it will be a square plus c square x square over a square, and plus 2cx. So it will be x square plus c square plus 2cx plus y square, which is equals to a square plus c square x square divided by a square plus 2cx. So if you notice that these two terms are same and in a same sign, if I move this factor on this side, then it will be cancel out with each other. C square x square over a square minus x square plus a square, which is equals to c square plus y square. So I take a common of x square, so it will be c square minus a square divided by a square plus a square, which is equals to c square plus y square. So if you see that we already discussed that the distance between a center and this vertex is a, and the center and a focus distance is c. But what is about this minor axis length? Means this center to this vertex means minor axis point. So to find this, if I draw this line over here. So if I draw a rough parabola over here, means I have this parabola and this point is a center point and this point is, I suppose, a point B. So I know to find this length, and here is a point focus F2, which is C0. So if I draw this line over here, means drawing a point B to this focus point, and we know that this length is C length, and suppose that this length is A and this length is B. So we find the value of B. So by Pythagoras theorem, it says that A square, which is equals to B square plus C square. Then if I would require to find the value of B square, so B square is equals to A square minus C square. So we find this value to arrange this factor in this form. X square, A square minus C square, if I move this factor on other side, divided by A square, plus Y square, which is equals to A square minus C square. Now we will find the value of B, which is I find here. As in this step, we just divide this factor on both sides. So this factor can be cancelled out and this will be also cancelled out. So we will left with x square over a square plus y square, which is equals to 1. And this factor is also divided by a square minus c square. So in the next step, this value is b. So x square over a square plus y square over b square, which is equals to 1. This is a final equation of the ellipse when the major axis is on a x-axis, or we say that the foci lie on a x-axis. Foci, in that case, which is plus minus c0, we have to find a center, which is 0, 0 means center is at origin. We also find the center to focus distance. Center to focus distance, as we say that the distance of the center and focus is c. So by using this formula, we find the value of c, which is equals to a square minus b square with this radical. And we will find the vertices as well, which is plus minus a0, and co-vertices as well, which is 0 plus minus b. So we will derive all these equations and this final equation over here. So we will discuss the equation of a parabola when a major axis is on a x-axis, means in this way. As this is a x-axis, which is a major axis in that case, because our foci lie on this axis, that is why this axis is a major axis. Suppose is F1 and F2. Here is our center point. So in that case, the equation we will find it. And the other possibility of the ellipse when a major axis is on a y-axis. What is the meaning of the major axis? Means that axis where the foci are present, or in other words. So this shape of ellipse is just a second possibility of the ellipse when a major axis is a y-axis and a minor axis is a x-axis. Here is a center of this ellipse. So here is a question, is that the equation of the ellipse, how to remember the equation of the ellipse in both of the cases, that x square divided by plus y square divided by, which is equals to 1, and in that case it is also the same, which is equals to 1. Always remember one thing, that the length of major axis in any case is always 2a, and the length of minor axis in any case, means any one of these cases, is equals to 2b. So this defines the equation, means here the major axis is on x-axis, So the length of the major axis is 2a. So remember that whenever the major axis, so x square over a square. For minor axis I will use b, which is b square. In a similar way, if you notice that here the major axis is y-axis, and in y-axis the length is, we revolve with a factor b. So x square over b square, and the minor axis is x-axis, so we will use b over minor axis, and for major axis we will use a. So in here is the simple technique. We will remember the equations, and just to see the equations we can imagine that which ellipse is that form. What is latus rectum? That a line passing through a foci, means these two are foci. A line passing through a foci and perpendicular to major axis. That here is a major axis, which is the x-axis, and a line which passes through this focus point. Both of these focus point is called a latus rectum, and the ends of this line is on a curve, means on a ellipse. In a similar way, in that case, a line passing through this focus and perpendicular to the major axis, and both the ends are on a curve or ellipse, is called a latus rectum. So this is a latus rectum. And the length of the latus rectum, what is the length of the latus rectum? In each case is 2b square over a. So it's all about today's lecture about the ellipse, equation of the ellipse and elements of the ellipse. So it's all about today's lecture. If you like this, then don't forget to subscribe, like, comment and share.